an ant.
And actually, if Jose were to turn it upside down, of course, it would be our classic Mickey Mouse.
That looks like a water bug.
Why would you have a water bug? Let's go on and see.
Surface properties of water. Hydrogen bonds make it harder to break through the surface of water. Surface tension minimizes the surface area of the liquid. If the pressure is strong enough, the pressure can penetrate through the liquid.
I have a question. What happened to Alex? He's not doing anything.
You do the next slide! No excuses! Any questions?
Yeah.
None? Good.
Yeah, what kind of creature is that? An ant? Water bug? What?
I don't know, it's some kind of water bug, maybe. You do this one.
Heat capacity of water. Heat capacity of water can be 1 calorie of heat energy to increase the temperature of 1 gram of water. For example, on a sunny day, water absorbs the heat energy of its environment. The air temperature decreases. At night, the heat from the water is transferred to its cool environment. The air temperature increases. Water is a storage medium for solar energy.
Did you get all that?
Yep.
I like that. Mr. Witt, nice.
Put a lot of work into it if you do that.
Yeah!
The heat capacity of water. So basically, water absorbs heat. Okay, I like
Water
that.
absorbs heat from the sun.
And that would have an advantage in life because we would stay warm because actually the water in our body would actually retain our warm bloodedness.
However, in daylight savings time, well,
in daylight savings time, yeah, I want to hear this gem of wisdom here. Go ahead.
when it gets darker, when it comes to nighttime, it has 2 different cycles. The sun will make our outside world warmer, and the water absorbs the heat energy from the sun. However, will it absorb the sun's heat energy if it becomes ice? No, because ice can't be penetrated unless the heat energy is strong enough to melt through it.
Ashley, is he telling me that because water absorbs heat, an ocean current down at the equator would absorb a lot of heat up the water? The water would then travel north and actually make the northern climate a little milder in the winter?
I don't know, I wasn't paying attention.
I think he was telling me that. So, actually, and this is a big part here, Beatrice, that's why it doesn't get like totally crazy cold in Massachusetts, because we have an ocean current from the Gulf of Mexico coming up here because of this property of water. Wow. Jose, you're a genius. Although Alex read this slide, so he's the genius.
Well, I guess you can say that.
Nicely done, guys. Nicely done. And that is good.
I was right about what I said, right?
Yeah, exactly. And your last line there is really, really important. Water is a storage medium for solar energy. And without that kind of circulation of water temperature, we would ice up in the North Atlantic and would change the flow of water. So we would actually become colder in the summers, the fall, winters, year round, and it could have devastating effects on us and life up here.
So basically you're saying the water climate can be threatening at times.
Sure. And what would happen is, as we would become colder, the equatorial, the area around the equator, would get hotter.
The equator would get hotter,
yeah.
and it would probably cause a tsunami because underground it's so hot, the water can't take it. It has to be released.
Well, and that's another good point. When you get those changes of mix of hot and cold air, it
And-
does create storms.
And tsunamis can actually kill people because there was something on the news about that hitting Indonesia.
And over the ages of the Earth, the years of the Earth, Greg, what was happening is we would go into ice ages, and ice ages are partially responsible because of this. The flow of the ocean currents get affected. So we could have had a planet that was extremely cold in the northern hemisphere and extremely hot in the southern hemisphere. But we've kind of got a blend of the two now in certain areas. So that's cool. Good slide, guys. Good slide.
Observations here.
Good slide, good observation, and I like that. Nice tropical palm trees in the back.
We decided to put backgrounds for our PowerPoint.
And are these clouds? Wow.
No, they're
ice.
They're
How do you do that?
they're snow.
Yes, but how do you do that?
How do you put a background on?
Yeah.
Ah.
You get one from the internet or like from your paintings.
Yeah.
Then
but-
you can go to your PowerPoint, then click on background, then fill effects, then picture. Then you can select the picture you want. Then you can insert it to your slide.
Okay.
Yeah,
You gotta
and
save it
good point. So you could actually have any background that you want. You can change the background on each slide. Which
True.
is good. Excellent. That's all right. Ready? Go ahead.
The vaporization of water. Due to hydrogen bonding, water absorbs an immense amount of heat before it can vaporize. The heat of vaporization is the amount of energy needed to convert 1 gram of a substance from a liquid to a gas at the boiling point. The reverse vaporization is condensation. Temperatures would be hotter in the tropics since the water didn't absorb heat while evaporating from the surface of the oceans that surround it. Temperatures in the polar regions would be colder if the water vapor didn't release its heat while condensing out of the air.
Woo! Guess what was my favorite part of that slide?
What?
The distracting gulping and grunting in the background. Wonder who that could have been.
Well, actually, that was a good companion slide to the slide before, because this really spells out the fact that it has an effect on our entire.
Yep.
Another example, but it might be a little out of topic. But this can also be an example of glaciers, because in the polar regions, glaciers are gigantic flows of ice which slowly move across the Earth's surface.
Okay. And what could potentially happen, because of the coldness there, it would take a lot of heat or radiant energy in order to melt those ice floes. I like that. And Greg is gulping at this whole concept. Refresh my memory about how much does a gram weigh? What would be an equivalent object of a gram? A what? I'm sorry, I couldn't hear you. No, an ounce is much heavier than a gram, actually. Much heavier. A gram, the weight of a gram is roughly about 2 sheets of paper or a small paper clip. That's about 1 gram. All right, nice slide.
Ice. Ice forms at 0 degrees Celsius. Ice has 10% greater volume and a lower density than water. Ice is one of the very few solids that float in its own liquid. Ice also melts at 0 degrees Celsius. It can also be used for a decrease in swelling and pain from an injury.
Because obviously it's going to equalize the heat. Now, can ice get colder than 0 degrees?
Yep. Yeah.
Yeah.
Because it is right now. Well, it used to be in the North Pole.
But the opposite is not true. Water can't get higher than 100 degrees because it becomes steam. Okay. Now, there's no state of matter lower than sort of your solid form, so you can actually get colder and colder.
You can get higher than 100 degrees.
Exactly. So that's why that liquid has a defined range sort of in there. All right. Any questions there? I like that. So that's the reason that ice floats.
aqueous solutions. Aqueous solutions are water samples containing dissolved substances. The dissolving medium is the